These first two are pretty simple because they're already in a form where we can solve. So here's what we're going to do. We are going to do a new kind of technique. You've probably never seen anything quite like this before in order to solve this, but it will come up again in this course, and then it comes up in other areas of mathematics. So it's a sort of this new technique that we need for different kinds of problems. Okay, so what I'm going to do is draw a number line, and I'm going to think about the three different options we have there. Yesterday, when we were solving a linear inequality, we talked about how you solve it the same way for the most part as a linear equation, but what you end up finding is the threshold where it goes from being true to not true, right? And then a bunch of values to one side are all true and a bunch of values to the other side are all not true, kind of thing. Like, don't satisfy the inequality. So in this case, it's similar where we're going to solve it with the same technique as we would to solve a polynomial equation, where we will always set it equal to 0, put it in factored form, and look at the factors that make it balanced. But again, each one of those is actually going to be a threshold from where it'll change, possibly at least, from true to not true. So what does that mean? Okay, so I have answers at -3, -2, and +1. You don't have to mark all the positions on the number line. We just kind of do it this way. But it is good to sort of do it to some kind of a scale. Like, I left a bigger space between -2 and 1 because there are other integers in there. You'll notice that will help. Okay. And again, it goes on this way forever that way and forever that way. And here's what we're going to do. We're going to test values in each of those intervals and see what it gives us. Is it greater than 0 or less than 0? So for example, I'll start on the left and I'll pick a number that is somewhere in this interval. Okay? And I like to pick a bigger kind of number, and a round number is probably easy to do. And so I usually go with something like -10. Okay? So if I think about this is like yesterday when we talked about checking your answer. Does it work for this value of x? Does it work for that value of x? That is exactly what we're doing. So when I plug -10 in for x, is what value do I get? So -10 minus 1 makes this negative. -10 plus 2 is still negative, is -8, so it's still negative. I don't actually even care about the number. I only care about the sign. You'll see why in a minute. And -10 plus 3 is -7, so that's a negative. So I get 3 negative numbers, multiply them together. I don't care what the value is, but what's the sign? Hunter? Negative. And then you can see that when I'm talking about these thresholds, starting at -3 and every number below that. So if I put -4 in there, it would be the same, or -5. I chose -10 because it just, you'll, after you practice a little bit, you see it's kind of nice to have a bigger number. It makes it a little bit easier. And whatever happens, all those values are going to be negative. So does that satisfy this inequality or not? Bishoy? No. Correct, it does not, because we're looking for when that is greater than or equal to 0. And if the value is negative, it's less than 0. Okay, so let's do the next one. I don't usually write those signs in. That's just kind of for the lesson. Let's do the next one. So we have to pick a value. This gets a little bit trickier, but between -3 and -2, you get stuck with a fraction, unfortunately, but that happens often enough. So if I do -2.5 minus something else, that's still negative. -2.5 plus 2 is still negative, but -2.5 plus 3 is positive. Right? Is everybody able to follow that? You get that? So a negative and a positive multiplied together will give me a positive here. Whenever 0 is the value that you can use, I would strongly suggest you use it. Again, it makes the math easy because this is going to be negative, this is going to be positive, and this is going to be positive. A negative and two positives makes a negative. Very different way of solving, right? Like we've put it in a form where we can do some tests and interpret the results of those tests. But it's not like old school math class in elementary school or in grade 9 or even for the most part in grade 10 where you do a bunch of work and the answer is x equals 10. Right? Like there is no process for that in this case. And then I'm going to pick a big number like 10, or you could go even bigger if you want, 100 or 1,000,000, whatever, right? So 10 minus 1 is still positive, positive, positive. 3 positives makes positive. Okay, yes? Yeah, that's right. That's what that would mean. Anything greater than 1 is in this interval here. Yeah. Does that make sense? Remember, it's like a threshold. We know that it's equal to 0 at each of those points. Like you better know that from the previous 2 units. That when x equals 1, it equals 0. And I want to know when it's bigger than 0 and when it's smaller than 0. So I know where it's flipping back and forth between those values. Okay, so now I can interpret this answer. And how am I going to interpret it? Well, apparently this is true between the values of -3 and -2 and above -1. And it's greater than or equal to, so it's inclusive. So if I was going to do interval notation, it would look something like this, including -3 and including -2. Okay, and including 1 to positive infinity. Any questions about that? Okay, let's try another one. So again, this is already in the right form. So we've got -4, -1, and +3. So if I, be very, is that a question? Okay, go for it.
So you could divide both sides by -2.
Ooh, nice.
And then you would have to change the sign.
I like that idea. So that's probably the best way to do it, in fact. I'm going to skip that and show you a little bit why, but then you can go back and think about why this is actually an easier way to do it. If we divide both sides by -2, because I have 0 on the other side, it's still 0, right? You have to flip the sign, but then it does make it a little bit easier to work through. Okay? If you keep the -2, you have to take it into account in your final answer. So for example, if I start from the left and I'm looking for some number that represents that first interval, -10. -10 plus 4 is -6, but when I square it, it becomes positive. So this one's going to be positive. -10 plus 1 is still negative. -10 minus 3 is still negative, right? But I have 3 negatives because I have this one as well, and people will forget that. And that's why getting rid of that number might be the better way to do it. But you got to flip the sign, otherwise your answer is going to be entirely backwards. So one way or the other, you got to make sure you're careful. Okay, so this is 3 negatives, which makes this value negative. And in fact, I would encourage you, either for this example or for a different example later, to go back and try it the other way. You just sketch it, like quickly kind of jot it down and see how it'll give you the same answer. But the tests will all look different. Okay, so between -4 and -1 is -2. What happens in there? I get, this is still positive, right? Because when you square it, it's always going to be positive. That one's always going to be positive no matter what. -2 plus 1 is still negative, and -3 is still negative. So 3 negatives. Again, this one's still negative. People will get in the habit, you'll notice the pattern, that it very often flips. Negative, positive, negative, positive. But it doesn't always. Now, if once you make all the connections involved in this, you'll figure out when it does and when it doesn't, and that's fine. But this is a technique that we use, this testing technique that you need. Like if you find a way that you think is better to solve these, be very careful. Okay, this is a technique we use in mathematics that you should know how to use. And on a question like this, I'd probably want to see your work, right? Okay, next one, we'll use 0. So that gives me positive, positive, negative, negative. So this one is going to be positive. And then if I pick a big number like 10, I get a positive, and a positive with one negative. So that interval over there is negative. And the question is, when is this less than 0? So I'm looking for the ones that are negative. Okay. So let's see, x is an element of the real numbers such that, now be careful, there's one other little trick to this the interpretation of this answer. Does anybody see it? Justin? We're not going to flip the sign. I mean, if we did it the other way, we would flip the sign, but in this case, we don't have to. There's what? Yeah, good. There's a bit more to it than just that. What happens right in between those intervals? So at -4. Yeah, it is 0. Yeah, good. Hunter? X, yeah, why do you say that?
Because it doesn't have the line underneath the sign.
Yeah, this is, when is that expression less than 0? Not less than or equal to. So it's equal to 0 at -4. So at -4, it's not satisfied. So even though we have two negatives side by side, in some cases that might count as like one interval, if you follow me. But in this case, it doesn't. So when x is less than -4, when -4 is less than x, which is less than -1, and when x is greater than 3. So if this was a less than or equal to, you would put these together probably, I think. You wouldn't have to write them as two separate intervals. But because it doesn't include 4, we need to account for that. Any questions? Okay, why don't you give this one, excuse me, a try. It's already factored. There's a lot of intervals in this one. Don't miss the 0. And this time I did divide out the negative because then that's like one fewer negative I have to worry about. I don't have to worry about missing it because that would be a common mistake, especially if you're trying to go fast. Okay, do you try the tests and see if you can get them. Okay, and then you can check your answer against mine, see if you got the test right. This one does flip back and forth. Positive, negative, positive, negative, positive. If you didn't remove the negative, yours will look a little bit different because you're going to look for the intervals that are greater than 0, but you're going to get the same intervals. Yeah, and that's what I'm talking about. It'd be worthwhile to try it yourself and see. So, for example, if I left the negative, that's going to add one more negative into the equation for each of them, and those signs are all going to flip, right? So it would start at negative, positive, negative, positive, negative. But then you're looking for the ones that are greater than 0. So it's going to be the same intervals. It's just going to look a little bit different. If you can't visualize that, I would suggest you try it. Or if you did the answer different from me, then you can just look at it different from me. Okay, so try to write based on that. You can try to write where are the intervals where that expression on the left is less than 0. So I got 2, from -5 to 2, and from 0 to 3. And not inclusive. Round brackets, we do not include those points, right? Because it's less than, not less than or equal to. Everybody good? Yes, Alex.
How are you going to use the brackets as opposed to X's and
The question will tell you. Or if it doesn't, then you could answer it however you want. So the question might say answer with interval notation. Like I think the homework did yesterday too, right? Or answer with set notation or whatever. And if it doesn't say, then it's your choice. Okay. When is f at x greater than or equal to 0? So just read this one from the graph. And all the way here. Okay. And here. And here. So you can go ahead and try to write that. Another great example of why we graph things and why we do both the algebra and the geometry, right? So what does this, like, we know how to solve this expression. It's pretty easy. But if you think about it sort of abstractly, what does it mean? When does, like, for what values of x does that expression on the left equate to a number that's greater than, in this case, sorry, 0, right? So when does it resolve to something greater than 0? Like that makes sense. I mean, we all get that, right? But if I think about that as a curve, when is it greater than 0? Like you visualize it in those locations is when it's greater than 0, or in this case, greater than or equal to 0, right? So you can really get a visual of exactly what it is we're finding. Like this is a visual representation of the answer. Okay, so it would be negative infinity to 1, 2, 3, 4 to negative 4 and inclusive because it's greater than or equal to. And let's see, negative 1 to 1 and then 1, 2, 3 to positive infinity. Questions? Yep. The infinity is always a round bracket because infinity is not a number that you ever get to. So it's like a technicality in mathematics, and mathematicians would be very picky about that. I think that like we don't include infinity because infinity is just like a symbol that represents an idea that it goes on forever. It's not a number. Woo! All of a sudden it got a lot harder. So how would we solve a question? So all those were already factored for us, right? And we were just interpreting the answer. That was the new part of today. But you already have the skills of how to solve this. So can anybody describe how you would go about solving this one? Justin?
Factor each side separately.
Interesting. No, that's not going to be a great way to do it, though.
Put everything onto one side, set one to 0, and then factor.
Right? We want to move it all to the same side, set it equal to 0. If we factored both sides, it wouldn't be worth our time to do that. But you could imagine what you get, and then where would you go from there? That would be tricky. We kind of do something like that in the next unit, though. So it's interesting. Anyway, but for now, no. All we ever do is move everything to one side and set it equal to 0, and then factor it and put it in the form that we've been doing. So go ahead and give that a try. Okay, so I got that. That should be pretty easy because all you're doing is collecting like terms. Yeah. Oh, sorry, go ahead. Are you sure? Oh, okay. Is that right? Is anybody else done? That's what you got, Sean? Okay, and then we interpret our answer. So if you're not that far yet, it's okay. So let's see. I've got -2. I have +3/2, so positive a half. Or sorry, 1.5. And then +3. Once in a while, you get a really nasty fractions that make it tricky. But in this case, it's actually not that bad because you can pick integers. Like you're going to pick nice integer values in those intervals. So I could use -10, 0, 2, 10, or something like that. I think that's everything. Yeah. Okay, so that's the solution I got. Again, we talked about this a little bit previously, but you could also think about those as two separate cubic functions. Okay, and so you could graph it like with graphing technology, something like that, and think about where is the one on the left greater than or equal to the one on the right. Doesn't that make sense? Like we simplified and thought of it as maybe one function, but the way it's presented is two functions. So we know how to solve for points of intersection between any two polynomial functions. Now we know how to solve inequalities involving any two polynomial functions. Interesting. We'll do all of that. Any questions? All right, there is the practice.